Okay, now let's go back to the idea of convection. But before we talk about convection, we need to talk about density. Okay, I don't think I'll show you all the video. I think it's pretty straightforward. If let's say I have a mixture of honey, water, and oil, right? This is how the three liquid, right, will spread themselves up. Okay, water, oil, and honey. Okay, and this is because this is the densest. Okay, and this is less dense or least dense. Okay, while water is like in between. Okay, so explain in your own words how an object floats or sinks. Okay, it's because of density. So that's because like for a certain given volume or area over here, okay, you have like different number of particles, and this different number of particles actually shows you like the density. Okay, so the one I label A is actually of higher density than the one labeled B. Okay, because just see, right, like while these have like 20 particles, okay, in this box, this only has like 8 particles in the same box. Okay, so obviously the density of A is higher. Okay, so with that, let's look at convection. Now, convection is about density, and let me just show you all something that I found online. Okay, here, yeah, this thing is like quite cool, right? Okay, so what happens over here, right, is it's not really convection, but it's showing you that hot liquid, actually hot fluid, right, they actually have lesser density. Okay, so okay, now cool, right? Okay, now a lot of people think, right, wow, you mean a hand can make water boil? Okay, so now this is not boiling. Okay, this is definitely not boiling, even though you see bubble here. Okay, the only reason why it's boiling is because the heat transfers from the hand to the glass, right, and it actually heats up the air inside the bottom bulb of this entire thing. Okay, so when you heat up the air expands, right, and it will want to go up to the higher region. Okay, so as it goes up to the higher region, it shoots up through the liquid. Okay, bubbles start to pop up through the liquid. It seems like it's boiling, but it's really not. Okay, so if you want to buy it, you can like go on to this website and buy it yourself. Okay, the description is here, what's happening. Okay, so maybe you want to pause and like take a look or like what's actually happening for this whatever this thing is called. Okay, yeah, but that's an interesting toy, and it doesn't really link with convection current. Okay, but it has to do with density. Okay, now convection in fluid, liquid, and gas is a process by which heat is transmitted from one place to another by the movement of particles how come the rate doesn't work? Okay, movement of particles in fluids. Okay, and this movement is caused by density change. Okay, so occurs in fluid, liquid, and gas, but not in solid. Why not? Because solid contains fixed position particles. Okay, what we want are particles that are free to move about, fixed position particles. Okay, now density changes due to difference in distance between particles. Okay, now hot fluid rises while cold fluid sinks. Okay, in other words, right, if you have forgotten, hot is less dense. Okay, cold is denser, right? And you have to be able to explain in terms of distance between particles also. So for this, right, the distance between particles are like closer, right? For this, right, the distance is actually further. Okay, now convection in liquid. Okay, so the circulation of a liquid in this manner is called convection current. Okay, so let me show you all a video on convection as well. Okay, so here's a video. I think this shows convection current pretty well. Okay.
We have some chickpeas in a beaker of water, and we're going to bring it to the boil. By heating it up, we can follow the convection currents in the beaker of the water by watching the movements of the chickpeas. The temperature, they gain this.
Okay, so so over here now, over here, right, convection current has not been set up yet, but after a while you realize convection current is being set up, okay, and you realize that the chickpea will actually start to move up and then go down again.
Create a low pressure zone or a lower density.
Okay, and therefore, right, this is actually convection current being set up over here. Okay, they call it low pressure zone, but actually they are not wrong. Okay, but what we usually use is a low density zone at the top and a high density zone at the bottom. Sorry, low density zone at the bottom over here. Okay, because this is like hot liquid, and over here is high density, it's like cold liquid. All right, so it will sink down. Okay, and like over here it shows very nicely. Okay, so when heat goes here, okay, the heated liquid goes up, and then it transfers itself with the colder liquid. The colder liquid sinks, and then the colder liquid gets heated up, and then it will just continue on in this manner. All right, that's the idea of convection. Okay, now convection current set up due to difference in density. All right. Okay, water at the bottom of round bottom flask is heated. It becomes over here. Okay. Yeah, I think it's pretty straightforward, right? Okay, so these are the 3 points on your notes that you have to write down. Okay, so if you write it down, it will look like this. Okay, now the idea, right, is really about density. Okay, so yeah, let's just go back. Okay, alright, so convection current set up due to density. Water at the bottom of the flask is heated, then the water will expand. Alright, not the particle expand, the distance between the particles increases. Okay, so fluid is less dense, start to rise, cooler region of the liquid in the upper part is denser, then it starts to descend. Okay, yeah, so like let's look at convection in terms of sea breeze and land breeze. Okay, so over here, I think I'll just show you all the slides, okay, for you all to like write down the points first. Okay, so just pause if you need to. Okay, if not, yeah, let's just continue. Now, what happens is land heats up faster than sea. Okay, so that's the idea of daytime, right? Okay, so the land heats up faster than the sea. Now, then the air above here it warms up faster, and then it rises. Okay, while the air above the sea is cooler. Okay, therefore it sinks. Okay, and this actually creates a convection current, as you can see. Okay, so the hotter air will actually start to go here, while the cooler air will actually start to come here. Okay, so if you are standing here, what you will feel is that the wind is coming towards you in this manner. Okay, now for land breeze, right, is the other way around. Okay, it's like the same mechanism, but over here. Okay, if at night, right, as you walk along East Coast Park, right, you'll feel like if there's wind, it should come from behind the sea. Okay, and that's the idea of land breeze. Okay, so sea cools faster than the land. Okay, so at night time sea cools faster than land. Warmer air above sea surface rises, cooler air above land moves. Okay, so it's the same thing. Okay, moves to replace the warmer air above sea surface. Alright, now explain if land breeze can still occur if the sea is frozen. Can it? Okay, so it can't. Okay, so if the land breeze, for land breeze, right, Okay, now if the sea is frozen, right, so this is frozen. Now what will happen? Okay, so think of it this way, right? Land and sea. Now this is frozen, so obviously now you have cooler air. Okay, so now this will be hotter. Okay, and therefore the wind direction should change. Okay, so if your lake is frozen, okay, what you get is actually sea breeze. You're actually getting this. Okay, so actually the breeze can still happen, but this will be sea breeze instead of land breeze. All right. Okay, now let's talk about the application of convection. Now air conditioners are best positioned at the top. Okay, and I think I mentioned briefly about this in class. Okay, near the ceiling of the room. Why? Because cold air, which is denser, sinks, while warm air, which is less dense, rises. Okay, and this happens until okay, so this entire process. Okay, and this entire process will stop at thermal equilibrium. Okay, so cycle repeats. Cycle repeats. Okay, until air temperature is the same as the temperature set on the thermostat of the air conditioner. Alright, so it's pretty straightforward. Your aircon has to be placed here, okay, because it's there to absorb the heat from the hot air. Alright. Now, hot water system, right? Is slightly complicated. Okay, so please take some time, pause over here if you need to, and then look at what's happening. Okay. Now, if you have already paused and like look at the labels, okay, so the boiler is over here. Now this will cause hot water to go up, right? Then this is your hot water storage tank. Okay, so all your hot water will be placed here. Okay, so I'll just put red color water to show that. Okay, now this is the cold tank. Okay, and what happens is that the cold tank actually goes down all the way. Okay, so cold water go down, the boiler will boil it, and then it will go up and then feed into the hot water storage tank. Okay, so now when you on your heater or not, you can draw water from either this place or this place. Okay, so it really depends whether you on your heater or not. Okay, so I explain why the boiler of hot water heater is placed at the bottom position. Okay, because if you boil the hot water has to rise. Okay, while the cold water will sink. Okay, that's why the boiler is placed at a position. That's the best position. Alright, and then we are done with convection.